In this video, we start our discussion about the Spring Framework. Spring Framework is the most popular Java web framework by a fairly large margin. In software development, popularity is actually quite important. If a technology is popular, you know it probably has good performance. It's probably reliable and secure if many people are using it. And it's probably easy to find support or get answers online because, again, many people are using it. The most popular technology may not be the very best in all these categories, but overall it must be pretty good for everybody to use it. Spring Framework is indeed all these things and more. I think what sets Spring apart from other web frameworks like Struts, Tapestry, JSF, GWT, and so on is that it goes beyond just web development. In fact, in this video and the next, we'll use Spring in Java console programs, and we'll see that the concepts and technologies used in Spring, like inversion of control, aspect-oriented programming, decorative transaction management, and security and so on, are not just for web applications, but also useful for all applications. And this makes Spring a perfect fit for this class. I always like to say that this class uses web development to talk about software development in general. Our real goal is to study concepts and techniques for developing complex, large software, and for that there's a lot in Spring that we can learn. Spring is a very complex framework. This is an architecture diagram of Spring from many years ago. Today's Spring has much more components than what's shown here, but since they never provided a new diagram, I just keep using this one. The purpose of this diagram for us is not really about showing everything about Spring. I just want to use this to show the main components and how they are related to each other. And in particular, you can see that the core container here, also often called the bin container or the IOC container, is a foundation for everything else. And this highlighted part is our focus today. Let's first use an example to motivate the need for the so-called inversion of control in software development. Suppose we want to access some user objects stored in a database using the data access object design pattern. Let's first look at the code, and then we'll explain the DAO pattern. In this example, we have a model class user. What's in the model class is not important, but let's just say that it has an ID, first name, last name, and email. We know that we want to save user information in a database, but we don't really care which database we use. For example, you can use MySQL, or you can use some other database systems, or you can even just use a file to store the user information. Regardless of how the data is stored and accessed, we do want two things. We want to be able to get a user object with a given ID, and we want to be able to get all the users as a list of user objects. This is the purpose of an interface. It basically says, these are the operations I want, and I don't really care how you implement it. An interface, of course, is not enough. We do need at least one implementation of it to do the real work. And this is an implementation of the user DAO interface using JPA. Suppose we store the user information in a relational database. And this is how we can use all that in a web application. For example, suppose we want to display all the users on a page. We can call user.DAO.getUsers to get all the users, and then pass a list of user objects to a view to display. We haven't really covered Spring MVC yet, so you don't know what a model map is here, for example, but that's okay. This is just an example of using data access code inside the MVC controller. So knowing all that, what exactly is DAO? and why we go through all this trouble instead of just using JDBC in controllers like what we did in CS3220. Well, DAO is a design pattern called Data Access Object. A design pattern, by the way, is a software design best practice to solve a particular problem. And the problem here is accessing data in some persistent data storage, like a database, as shown in the picture here. Notice that DAO sits between the application and data storage and provides operations to get data objects in and out of the data storage. By having this middle layer, the application code becomes independent of the data storage. For example, the controller here only needs to know that it can get all the user objects without needing to know where they come from. So we could store the user objects in relational databases, or we could store them in object-oriented databases, or just in some files. We can use different database systems, and we can use different data access methods like JDBC or Hibernate and JPA. And we are free to switch to a different storage system or access methods without changing the controller code. If you look at DAO in this picture, you can see that it basically creates a separation between the web application and the data store. And this is a common theme in developing complex software. By creating these separations, we can divide a complex application into components that can be independently developed, tested, optimized, or even replaced. And that makes building a complex application a lot easier. In Java, DAO is usually split into a DAO interface and a DAO implementation, which means that there are two ways to declare a DAO object. You can use either the implementation as a type, or you can use the interface as a type. So which one is better? The answer is, of course, using the interface as type is better. And that's because this ensures that the rest of the code will only depend on the methods available in the interface, rather than depending on methods in a specific implementation. So if later we change to a different implementation, the rest of the code that uses user.DAO does not need to be changed. Note that I said the rest of the code that uses user.DAO. But what about this line of code that instantiates user.DAO itself? It turns out that the application is not really independent of the DAO implementation, because we must specify the implementation in order to instantiate a user.DAO object. If we want to switch to a different implementation, for example, replacing Hibernate with JDBC, we have to change all the controllers that has this line, and that can be quite a lot because user.DAO can be used in many different controllers. This is actually an even bigger problem than it sounds. Imagine that during development, we want to use a mock DAO for testing. For example, we may want to use a user.DAO that always returns 2 pre-created users when getUsers is called. With the way DAO is instantiated, it's very difficult to switch back and forth between different implementations, which makes testing with mock implementations practically impossible. So what can we do? Well, consider something like this. Instead of instantiating a DAO object inside a controller, let's create a setter for the DAO in the controller. So now the controller is truly independent of the DAO implementation, as it will use whatever implementation passed to it through the setter. This looks pretty good, except for one important question. Now who's going to call the setter to pass a DAO to the controller? Well, the answer is a framework like Spring, which will be responsible for instantiating the objects and pass them to application code. These types of frameworks are often called inversion of control containers or bin containers. And the term inversion of control means that it used to be the application code that's responsible for instantiating objects like now. But now the application code no longer has that control. If you think the term inversion of control sounds kind of odd, a more intuitive but roughly equivalent term is dependency injection. For example, here, user.DAO is something this controller depends on, and the framework will inject a user.DAO implementation into this controller by calling the user.DAO setter. Let's look at a simple example and see how this works. I have a simple Java class here called message, and this message class has a property called content. Notice the getter and setter here, and remember that in Java, properties are defined by getters and setters, not the same thing as a field. And here I have my main method, and inside it I create a message object, and then I print out the content of the message. If I run this code, we can see that the content is hello world. Note that we didn't set the content of message anywhere in the code, here nor here. So where did the value hello world come from? It, of course, comes from Spring, and more specifically, the Spring bin configuration file hello.xml. And notice that this configuration file needs to be on the class path, and in a Maven project, anything that needs to be on class path should be under the folder source/main/resources, and it's right here. So in this file, we can see that we define a bin called msgbin, which is a and this bin is of this message class, and we also set the content property to the value hello world. And if we change this to something else, let's say we say hello CS50 to 20, and run this again, it will say hello CS50 to 20. And by the way, in Spring, objects managed by the framework are referred to as bins. So you'll see the term bin, bins quite a lot when you use Spring. So coming back to this main method, notice that we load this bin configuration file and created something called the application context. Think of an application context as a container that contains all the objects managed by Spring. And then we use the bin ID msgbin, this bin ID, to get the bin from the application context, and then we print out the content property of the bin, which was set to hello something in the bin configuration file. So in this example, we can see that the string value hello world is injected into the bin msgbin. Now let's understand how this injection happens. First, consider how we usually create a new object. For example, suppose we want to create a new message object. We would say new message, the constructor. The Java virtual machine will process this call and return a message object. Note that in this case, the content property of the object will be null, because nobody will set it. Now let's see how it works with Spring. The first thing to know is that with Spring, you don't use new constructor to create an object. Instead, you create object through Spring using getBean. When getBean is called, Spring will look up the bean configuration file, and based on the bean ID and bean class, it will create a new object of this message class. And notice that the new constructor call will be called by the Spring framework instead of our code directly. And because the bean configuration also shows that the property content should be set to hello world. After the object is created, Spring will then call the setContentSetter to set the property to hello world. And then it will return the message object back to the application. So now we have a message object that has a content property with the value hello world. Now, this may sound like an awfully complicated way to set a property. But of course, Spring can do a lot more than this. Not only it can inject simple types like strings and numbers, it can also inject collection types like lists, sets, and maps. And most importantly, it can inject beans into other beans, which makes the framework very flexible and powerful. And in terms of ways of injection, the most commonly used is through setters, but Spring can also do injections through constructors. Now let's see another example. In this example, we'll show the injection of simple types, collection types, and class types. Starting with the bean class, or the model class if you want. So notice that I have 4 fields, integer fields here, A, B, and C, D. And if you look at getters and setters, I only have getters and setters for A, B, but no C, D, meaning that I have 2 properties, A and B, and C, D are not properties. I also have getters and setters for an integer array called numbers, corresponding to this field. And I also have getters and setters for a property called now, which is a date object. And for C and D, I can initialize them in constructor. So in addition to all that, I also have an output method. And this output method is just a helper method to print out what's inside the object. It will print out the values of A, B, C, D. It will print out the sum of everything inside the numbers array. It will print out the value of the now field. So notice that we are not giving any of these properties any value inside this class. We'll do that, of course, in the bean configuration file. Now this is the main method. Again, we create an application context from a bean configuration file, and then we get a bean called DJ out of that bean configuration and or application context, and then we call output. So if we run this, we can see that it indeed prints out a bunch of values. A is 10, B is 20, C is 15, D is 40, sum is 3, and the current time is September the 9th. So all those values are, of course, set inside the bean configuration file. And here we can see how each property is set. So for A and B, notice that they are simple types, integers. So we can simply say property name and then value. And this will give A and B the value of 10 and 20. And numbers is an array. So the way to set an array or a list is to say property and then list element, and inside the list element a number of values. So the array will have values 1 and 2. This is why we got the sum 3. And for the date property, because it's a data object, it's not a simple value anymore, we are creating another bin here, and we're referencing that bin, or in other words, we are injecting this bin into the DJ bin. And notice the syntax here is property name, and instead of value, we say ref or reference here. Now for C and D, notice that they are initialized in constructor, and here, this is how we can inject something into a bin using constructor arguments. Constructor arguments has an order, and the index starts from 0. The first one is 15, second one is 40, and that's why C gets 15 and D gets 40, which are shown here. So this example shows all the important elements and attributes used in a bin configuration file, and here's a summary. So if you want a bin, use the bin element, and the bin has an ID and a class. ID, of course, is a unique identifier, and class is a type of the bin. And to set simple types like numbers and strings, we say property with a name attribute and a value attribute, like here, property name and value. And for class typed properties, we say property and then name and reference. Reference is referencing the ID of another bin, so this one is name and then reference and the ID of another bin. And for collection types, there are a number of elements we can use. For arrays and lists, we can use the list element, and the next slide will show some examples of using other elements to inject a collection type. And for constructor arguments, we can use constructor arg with an attribute called index, again starting from 0, and then it could be just like a property, it could be a value if it's a simple type, or it could be reference, referencing a different bin. And here are some additional examples of setting collection properties. If you want a set, you can use set. And in Java, a set of objects can contain objects of different types. For example, here, this set will have a string, bar1, and another bin type called bar2. And if you want a map, you can use map entry. Each map entry has a key and value. And if you want properties, you can say props, and each property has a key and a value. So in Spring, injecting bins into other bins is called wiring. Let's use a more complex example to see how wiring works. So in your data structure class, you must have studied stack. It's one of the commonly used data structures, and it has this characteristic of last in, first out, or first in, last out. And the two basic operations are push and pop. Suppose I want to implement a stack, and So the first thing I would have is an interface that defines the two operations of stack, push and pop. Push would take a string value and pop will pop that string value out of the stack. And then let's say that I have an implementation of this interface I call stack1, and this implementation will use an array list to implement the stack. Now the actual implementation doesn't really matter. That's not the point. Here the important thing is that stack1 uses an array list to implement this stack. I also have another implementation called stack2, which also uses a list to implement the stack. Notice that if you compare stack1 and stack2, you can see that stack2 does not specify what implementation of list it uses. Remember, list is an interface in Java, and the array list is a specific implementation of list. So in stack1, we say we are going to use an array list, but in stack2, we say that we are just going to use some list implementation without specifying what implementation it is. It does have a setter, and presumably later on we are going to set an actual implementation to this stack2. Otherwise, the list will not be instantiated and will end up with a null pointer error. So two implementations, one uses an array list and one does not specify what type of list it uses. And then I have some test code. So in this test code, it will create a bin, and it will create a bin of this stack test type, and it will call test. So this class will use a stack, and it will call the test method to push 1, 2, 3 into it, and then pop, 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 and if the implementation is correct, we should see 3, 2, 1, the reverse order of the push. Now again, notice that in this class, we define a stack using the stack interface, but we are not saying which stack implementation it uses. Again, it has a setter, but no specific implementation, and presumably we are going to use Spring to set a stack implementation later. So this is what the bin configuration file looks like right now, and it says if you want a stack test bin, it's going to be of this class, and that's it, nothing else, right? Now, if I run this code, so I'm going to get a null pointer exception, and that null pointer exception happens here. And the reason it's null is because notice that there's nowhere in this class that we set the stack value, right? So this one is going to be null because nobody is calling set stack to set a stack implementation to it. So knowing what we know, we can do something like this. So currently, it's basically this bin. And this bin by itself does not work because it needs an implementation for stack. So what we could do is we could create another bin, and then we could wire that bin into this, or ask Spring to inject that into this. And knowing the syntax of all this bin configuration stuff, we can do that fairly easily. So all we need to do is say, hey, I'm going to create another bin, and I'm going to call that bin stack1, and this bin is going to be this stack1 class, and it's going to be 2220 Spring stack1. So once I have this bin, then we can inject this bin into this one, and the syntax would be property name and then reference. So the property name, notice that we have a setter here. It says set capital stack, so the property name will be lowercase stack. So the property name is going to be lowercase stack, and that is going to reference stack 1. And now if I run this again, notice that now it works. So we have push 1, 2, 3, and then pop 3, 2, 1. So this is how we can inject one bin into the other. And we can do something else too. So let's say instead of injecting stack 1 into it, I want to inject stack 2 into it. So let's say we're going to do stack 2, which is a different implementation of stack. Now, if we just do this, we are going to run into another null pointer error. And this time, you can see that the null pointer error happens here in stack 2. And the reason is we never instantiate the list in stack 2. And to solve that, of course, we want to create a list implementation and then inject that list implementation into stack 2. So it will look something like this. And let's say that we want to have an array list, and if I remember correctly, it's in the Java utility package. And this will give us an array list, and the first thing we do is we need to inject this into stack 2. So again, it's property name, and inside stack 2, the property is lowercase list because the setter is set capital L list. So the name is list, and again, it's reference array list. So if I do that, now it works again. Now it looks like this. And because stack 2 only uses a list interface, we are free to inject a different list implementation into it. For example, if for whatever reason we realize that array list is not giving us the best performance, maybe we want to use linked list instead. And so all we need to do is create a linked list bin, and it will be linked list, and let's call it list 2, and we'll put list 2 here, and it still works. And now linked list, we are injecting a linked list to stack 2 and then injecting stack 2 to stack test. So this is known as wiring in Spring. Now, if you look at this, it looks kind of nice, except that the bin configuration file can get quite complex when we have more than a handful of bins. So Spring supports another way to specify bins using annotations. Instead of explicitly specify all of them in a configuration file, we can just put annotations in the classes and then Spring automatically wire them together. So there are several elements used in Spring Bean configuration for this annotation-based configuration. There's a annotation config element, and this tells Spring that we are going to be using annotations. And then there's a component scan element that tells Spring to scan certain classes to look for those annotations. There are annotations we use to mark a class to be a Spring Bean, and then there's an annotation we use to wire those beans. Now, let's go over this one by one. First, the bean configuration file. Instead of using this bean configuration file, we're going to use a different one. Not this one. We're going to use a different one here that looks like this, or what's shown here. Now, the first thing I want to mention is I want to explain this XML namespace thing a little bit. We know that XML consists of XML elements, or tags, as we usually call them. The problem is that different developers or organizations may create different tags that have the same name but different meanings. For example, Spring may have a tag called bean, which means certain things, and I could create a tag called bean, which means something else. So to deal with this problem, XML uses something called XML namespace. So if you look at here, XML NS stands for namespace. So by combining the name of a tag and the namespace of the tag, we can make sure that the tag is unique. Note that this is very similar to the custom tags used in JSP. Remember that a custom tag, like the CIF tag in JSTL, is a combination of the tag library C and the tag name if. And this ensures that this tag is unique. And the XML space is basically the tag library for XML tags. Same idea. Now let's look at the syntax of using XML tag space. XML namespace. First, notice that this bean configuration file uses three namespaces. The beans namespace from Spring Framework, the context namespace from Spring Framework, and this XML schema instance namespace from w3.org. Each namespace is represented by a URI, which is similar to the URI for a custom tag library. The beans namespace is the default. Notice it says XML namespace and then the URI of the namespace. And the other two namespaces are not the default, so you'll say XML NS and then give a label to those two namespaces. Now, if a namespace is the default one, any tag from that namespace does not need a prefix. So notice that because bean is from this namespace, there's no prefix needed. If a tag is from a different namespace, then you need to specify the prefix. So context here means this tag is from this context namespace. Here's another way to write essentially the same file. Notice that this time we specify the context namespace to be the default. So annotation config and the component scan no longer need prefixes, no longer need a prefix. However, the beans tag now needs a prefix beans, which is a prefix for the beans namespace. So knowing how namespace work now is clear. what those prefix and column thing means. So moving on, let's first look at the annotation config tag. This tag activates the processing of a number of other annotations, like auto-wired and so on, which we'll explain in a moment. The component scan tag tells Spring to scan all the classes under the base package as well as all the packages under the base package. It tells Spring to look for classes under those packages that are annotated as Spring beans. So here we specify the base package to be stack, so it will look for Spring beans under this package and all the packages under this. So how do we annotate a class to be a Spring bean? Well, we can use one of these annotations. For any regular bean classes, we can use the annotation component. And for DAO classes, we can use the annotation repository. For controller classes, we can use the annotation controller. And for service classes, we can use the annotation service. Spring can automatically wire beans together, and there are two basic types of auto-wiring, by bean name and by bean type. By type is the default. There are two additional types of auto-wiring. Auto-detect means Spring will try both by name and by type until it finds a suitable bean, and constructor means the bean will be wired by type as a constructor argument. And we can specify auto-wiring type on a per bean basis or for all the beans. If a property needs to be auto-wired, we can use the auto-wired annotation. So combine all this, let's go back to this example. Here, I'm going to use this annotation-based configuration file, and the main method is going to be this stack test annotation. So it's similar to this, except that it uses a different configuration file. Now, notice that in this case, there's really no bean directly specified here. So in order to get a stack bean, a stack test bean, and so on, where we need to mark them as beans using annotation. So the first thing we do is we put component here. So this mark stack test as a component or as a Spring bean, and this way we can then get it from here. But of course, just stack test is not enough. We need to pass at least one stack implementation to it. So I'm going to put component here as well. So now we have two beans, stack 1 and then stack test. Now currently these two beans are two separate beans. They are not wired together yet. So I'm going to put one more annotation here, and I'm going to say this one should be auto-wired. So Spring will then automatically inject stack 1 into here, and then this whole thing should work. Let's try that. So now it works. Just like before, but now the configuration file is much simpler. So what if we also want to do like what we did before, inject stack 2 into stack test? We can make stack 2 a component as well. And if we run the code again, This time we are going to get an error. And if we look at the error, you can see that the reason there's an error is because it expected single matching bin, but it finds two, stack 1 and stack 2. It finds two bins, both implement the same stack interface. So in other words, when it tries to auto-wire this, it doesn't know which one it should pick, and it gives us an exception. So this is where we can use another annotation, and we can say qualifier stack 2, meaning that is it called qualifier? Okay, qualifier. And this will resolve the ambiguity of stack 1 and stack 2, both of them implementing the same interface, and we basically say here that we want stack 2. So if we run this again, now the previous error is gone, but we are having a new error, null pointer again. And this happens inside stack 2, and same error we saw before. The reason, of course, is because stack 2 never instantiated a list, and it relies on us to provide a list. So just like before, all we need to do is we can say actually I'm just going to copy and paste from here. And I'm going to inject, create an array list in here, and then inject this one into here by, let's first try auto-wired. Okay, so the first thing to note here is that when you use annotation-based bin configuration, it doesn't prevent you from explicitly specifying certain bins inside the bin configuration file. So you can still specify explicitly bin configuration here, as much as you want, and then the component scan will automatically pick up the ones that are specified using annotation. If we run this code, I think we'll get another error. And this error, if you look at the error message, it's a little bit not very intuitive. So this one basically says it cannot find any suitable bin of the type list of strings. Now, the reason it couldn't find this one is because notice that when you specify bin configuration like this, there's nowhere that you can use a generic type. In other words, this array list is going to be an array list of objects, and this list here says list of strings, so they don't quite match. At least they don't quite match based on the auto-wired standards. So if we want to use it anyway, because we know it works, instead of auto-wired, we can use the annotation resource, and we can say resource array list. And this time it works. So resource basically tells the container or the dependency injection engine that regardless of whether the type exactly match or not, just use this one. So This is how the dependency injection works in Spring. And to summarize, there are quite a few advantages of using dependency injection, or in other words, inversion of control. The most important benefit is the true separation of different components of an application. For example, the controllers and the DAOs. This allows those components to be independently developed, tested, optimized, and replaced, and that's tremendously beneficial to complex software projects. With dependency injection, the dependencies or the wiring of the bins are centralized in a bin configuration file. So if we want to replace some bins or components, we just need to edit one configuration file instead of lots of source code files. Or we can simply just use a different configuration file. And finally, Spring bins are by default singleton objects, meaning that once a bin is created, it's shared by all the code that uses a bin. Performance-wise, this is quite beneficial, as we don't need to recreate an object again and again. And of course, if you do want to create a new copy of a bin every time it's used, you can do that with Spring too. In Spring, those type of bins are called prototype bins, as opposed to the regular singleton bins. In this video, we introduce Spring Framework's dependency injection container, usually called Spring's bin container. For more information, please check out the first chapter of the Spring Framework documentation.